In this video, we are now going to look at how you can be able to display a text and characters on the LCD. And from there, you should be able to appreciate how a microchip is responsible for displaying any form of text on a display. Now, if you go to your Proteus, we can click on the component and we can select our Arduino Uno, and we can be able to select our LCD, (16:2) LCD, and we are going to use a protocol known as the I2C, or sometimes they call it the I2C, and this is responsible for selecting a specific data that can be adjusted with the clock and will be displayed on your LCD 8574 PCF 8574. So it is a 8-bit I2C expander, and once you are done, we can now build our circuit. You can import your Arduino and we can connect our LCD and our I2C. Now we will begin the connection, and we know that this microcontroller is responsible for transmitting data using the protocol, which is the I2C. Now we should be able to identify the pin for the clock signal and the data signal, and we know that from this particular I2C chip we can be able to locate what is called the SCL, which is responsible for the clock signal, and the SDA pin, it is responsible for the data. And now if we see from A4 and A5 of this Arduino Uno, we can be able to see that A4 is the data pin and A5 is the clock signal pin, and we can now be able to do the connection respectively, and we can connect the SCL to the SCL, and we can connect the SDA to the SDA. And from this second diagram, we can be able to see that A0, A1 and A2 will be connected to the ground, and we can connect them like this. And now we can be able to connect the LCD, and we can move our LCD here. Now we can be able to connect our P0 to the RS, and we can connect P1 to RW, which is the right, and P2 we can connect to the enable pin. And RS means the reset pin, RW is the right pin, and enable is a pin that enable this particular 16:2 LCD to operate. And we can continue to connect P9 to D4, pin 5 to D5, pin 6 to D6, and pin 7 to D7. And now our connection is complete. And since VSS is the ground, VDD is the source, and VEE is the adjustable for the brightness, because when you connect a hardware 16:2 LCD, you should be able to configure the pin. However, we are using the simulation model, we can leave it blank. And now our circuit is complete, and we will program this microcontroller and it can be able to display some form of text on this particular LCD. So you can open up your Arduino IDE and we can start to program. Now we have opened up our Arduino IDE and we have our Proteus setup, which is on the left, and our Arduino IDE. Now we will start to program, and firstly we have to initialize some of the parameters that we use, and we can type include, and we have the wire.age, and we have to include the use of the liquid crystal A to C. And when we initialize, this is now complete. We initialize the wire and we initialize the use of the I2C from our Proteus model. And now we will begin by define the liquid crystal I to C, and we have the LCD, and under this we now should be able to give the address. So when we initialize the wire, we are now specifying the address for the I2C, and because data will be transmitted serially, that means the clock will play an important role in determining the address. Since this is the output peripherals, it will be given an address. And if we use some other peripherals such as an input device, and we want to send information into the microcontroller using a serial communication, we now have to define the address of the input and the output. And depending on the clock signal, it should be able to determine which data can be transmitted to an output device or receiving data as an input device. Therefore, address becomes more important. And for this PCF8572, the address in which it should cater is 0 by 20. And this is the address when data is to be transmitted to the LCD through this particular I2C driver. We now specify the address in which this text can be transmitted to this particular LCD, and we can now define 16 by 2, and 16 by 2 is nothing but the column and the rows. And this LCD have 16 columns, so we have 1, 2, 3, 4, 5 all the way to 16, and the row data will be transmitted is 2 rows, 1 and 2. And once this is complete, we now have to type our code such that we now giving lcd.init. We now formally initialize the use of the LCD in our program, and we can give such that LCD dot backlight, which will be used, and we can have the LCD dot print, which is now the function to print our text. And we can be able to say hello what Proteus. Let's say hello Proteus, and this will be printed on the first column, and we can set lcd dot set cacher, and we can give 0 and let's say 1, and lcd dot, we have to print another text in the second column, and we can write something, let's say Arduino plus maybe LCD. And now this is our code that can be able to display the text on the first row, such as Hello Proteus, and it will now set the cursor to the position which is 0 and 1, and it will now print the Arduino plus LCD, which should be on the second column. And now I will explain the code. After the initialize, we enable the backlight of the LCD, and the LCD print is a command that is used to print the text or the string. And initially, when printing this text, the cursor direction will be 0, 0. That means we will print the text starting from the 0 column and 0 row. And after this, that means it is now on the row 1. And the second one, we now have to set the cursor to the column which is 0, and we have the 1 which is the position of the row, so column and the row. And we have row 1, and initially it should be 0, 0. That means 0 column, 0 row. And now we are moving one place down, that means in row 1. Because we start from 0 and 1 row, that means 2 rows, and we start from 0 to 15, which is the column. And then in this second row, we now print the Arduino plus LCD. And now we can compile this code to see if there are some errors. Since there are no errors, we can now be able to go to the sketch and we can export our compiled binary. That means we have to be able to get our hexadecimal code. And under void loop, we don't want to display anything. That means when this Arduino Uno, when we switch on, it should be able to display this text. And if we want to add some loop, we can later add some loop and then we can clear this display. However, for this initial setup, we now be able to see that it will only print this text only once. Later on in our video, we should be able to use a void loop to see some of the advanced result in which we want to display in our LCD. For example, a temperature reading or some digital data that needs to be transmitted for the user to see and verify all of these, we can be able to use the void loop. And now we can double click and we go to the place where we store our hexadecimal file. So we click the X file and we click OK. And now we can run the simulation to see how it will work. So when we click the run, we should be able to see that it is now printing the same text on our Arduino IDE, such as the Hello Proteus on the first column, first row, and we have the Arduino plus LCD on the second column. If we want to change the second row and we type something like how are you, and if we are to compile and if we export, we can be able to see how this text will change. Now you can be able to see it says Hello Proteus, how are you? So I believe in your later project, if you want to use the LCD to display some data or some variable reading, you can be able to use the I2C protocol, in which data can be transmitted via the SDA and the SCA, which correspond to the data line and the clock line of the I2C.